No, there's this one that's yellow, and it's like a string.
All right.
And then it's like a blouses out. It's so ugly. And mine is like orange. I love Lego.
Just as a reminder, a refresher. Where are the zeros? Just the X, not the Y. What does the degree have to do with the number of zeros? Close. Tells you how many zeros there will be. Now they're not always sometimes it might look a little different. In other words, this looks like a cubic, right? Because there's 3 zeros. But it could be we have what we call repeated zeros. Do y'all remember those? They either go through or they bounce, and sometimes repeated solutions are included. So this is not necessarily a cubic every time, right? But that's what we know. So it has, the degree tells you the most zeros that it can have, right? It can't have, if it's a cubic, it can't have more than 3 zeros. If it's a quartic, it can't have more than 4, and so on and so forth. Does that make sense? Y'all remember that? Okay. An even degree polynomial is always going to have an even number of zeros, and an odd degree polynomial is always going to have an odd number of zeros. Yep. Even degrees, because remember, it's not necessarily the most. This looks like a cubic, but it couldn't be a quartic because it's got an odd number of zeros. It would have to be an odd degree polynomial. Does that make sense? You can also look at the end behavior. Because it's opposite directions. Correct. That's correct. Because 2 of those could be repeated solutions. They could be going through. So even degree gives you an even number of zeros. Odd degree gives you an odd number of zeros. Because the degree is the most zeros you can have, right? Are we all tracking? Y'all remember this? What else I need to tell you? We break polynomials down into linear factors, right? Because the linear factors we can solve to find the actual zeros, or in other words, where it crosses the x-axis. So let's look at one, for example, before I talk about multiplicity real quick. You'll see that the only thing is some things are kind of cranked up a little bit here as far as factoring and things like that. I find that a lot of pre-cal, that's what happens, is we're just cranked up a little bit. It makes us excited, right? This is it. 37? Yes. All right, cool. What's the type? Quartic. Means it has at most how many zeros? 4. The most number of maxes or mins it has. Do y'all remember that? 3. N minus 1. N minus 1. That's your N minus 1 that you're thinking about. You can do that, yes. Or you can count the number of zeros. So say that again. Yeah. We hadn't quite got to that yet. Back to it, but that's okay. What do you mean? Adjust your window so you can see. Yeah. Hit that window button. Yeah, you look like a bird. Then we would have to describe them using where we said like pi over 2, 3 pi over 2, dot, dot, dot. All right, factor and solve. Find all the zeros algebraically. Mark said go. Find the zeros by factoring. Oh. You're right, we can't take out an x. Even though, even though it's, this is just, even though it's not a quadratic, right? Y'all are used to seeing something like this, 9x squared minus 37x plus 4, and that's a quadratic and we can factor it. But this is what we talked about is called quadratic form, where this first exponent is even. This exponent is half the first, and then the last is a constant. And if that happens, I can factor as usual. Do y'all remember this now? I can multiply the first and the last together. 36x to the fourth. What multiplies to 36x to the fourth but adds to negative 37x? Negative 1x squared and negative 36x squared. So now I have 9x to the fourth minus x squared minus 36x squared plus 4. What do you take out of the first two? Oh, well, I put mine a different way, yeah. X squared, I'm left with 9x squared minus 1. And then if I take out a 4 here, I'm left with 9x squared minus 1. So you should have, even if you got your factors backwards or different than mine, you should have still come back to 9x squared minus 1 times x squared minus 4, which that's exactly right. Those are two difference of squares. So I can break those down because right now they're not linear factors. They are factors, but they're not linear factors. They're quadratic factors. So I need to break them again because of the exponent too. Linear won't have an exponent on the x. That is correct. I'm slaying. All right, so you might need to go back and refresh on some of your factoring techniques. Remember, there's some patterns. Yes. You can put either one first. It doesn't matter. No, then you take out 9, not 3. If you did 9x to the fourth minus 36x squared, then you would take a 9x squared out. Yeah. All right. One more thing. Then we have something called multiplicity. So if I go through and I factor and I end up with something that looks like how many zeros does this one have? 5, but 2 of them are repeated, right? Okay, so I have x equals 1. That's a 0, but it has a multiplicity. Remember, multiplicity means how many times it's repeated. And then I have x equals 3 over 2, again with a multiplicity of 2. And then I have x equals negative 4. Of course, that one just has a multiplicity of 1, right? Oh, multiplicity? There's not a sign. Just write m. Write m. No, don't say times 2, because then that'd make you think times 2. Write m2. Multiplicity 2. There'll be a chart on your homework. Okay, almost. Almost. Now, we talked about multiplicity, and we talked about it being important for really one big reason, and that's what effect it has on the graph. If multiplicity is odd, then it goes through the axis, but if the multiplicity is even, it bounces. So in the case of this one, I bounce, and go through. Bounce through. Yes. A 90. That's good because you know how to do all this, right?